Welcome to the video lesson for solving rational equations part 1. We're working a lot with simplifying and combining rational expressions, but now we're going to actually be solving for the variable x. Our first step, generally speaking, is we want to attempt to cross multiply. The reason why we're going to cross multiply is because we will no longer have a fraction or a rational expression once we've done that. So we're going to go ahead and cross multiply here. 5x times 2 is going to get us 10x. And then we're going to cross multiply over here. And we get 3 times x minus 3 times 7. All right, then from there, we're just going to try and solve. We want to solve for our variable. I'm going to solve for x here. To do that, we're going to subtract 3 on both sides. And then to continue solving for x, we're going to divide by 7. And we get x is equal to negative 3. Now, it's very important that we check our answers. In this case, we only have one, but we're going to check for something that we call extraneous solutions. So an extraneous solution is an answer that you get when you solve your problem, but something that doesn't actually work when you plug it into the original expression. And that could happen for a variety of reasons. Sometimes we have numbers that give us zeros in our denominator. Sometimes, depending on the expression, we get some complex values, but you'll want to always make sure that you check it with the original expression. And again, extraneous solution is something that will cause the denominator of the equation to equal 0, and we can't divide by 0, so we know that that's not okay. All right, I'm going to go ahead and check it. I'm going to plug it into, again, the original expression. So we have 3 over 5 times negative 3. See if that's equal to 2 over negative 3 minus 7. Okay, so I have 3 over negative 15. That's supposed to equal 2 over negative 10. And if I simplify both of these, I get negative 1 over 5 on one side, and then negative 1 over 5 on the second side. So I know it definitely does work. Now, you don't have to physically write down the check, but I'm going to encourage you to always check because, again, there's going to be extraneous solutions, and if you don't find them, then you don't have the correct solution. Okay, let's go ahead and look at another example here. Okay, so our first step is going to be the same as it was for the last problem. We're going to go ahead and we're going to cross multiply. When you cross multiply, we are going to get 2x squared plus 5x. And then when I cross multiply on the other side, we get just 11x plus 8. Now this problem's a little different because I have an x squared, and unlike the last problem, we're probably going to have to do a little bit of factoring. So I'm going to combine everything onto the same side. I'm going to subtract the 11x and I'm going to subtract the 8. And when I do so, we're going to get 2x squared minus 6x minus 8 is equal to 0. Now at this point, we have a lot of options. The first option generally is to try and factor. If something factors easily, it's going to be a quick way to get our answer. Because it's a quadratic, the second thing we can try and do would be the quadratic formula. But I do notice right away that I have a greatest common factor of a 2, so we're going to take that out. And then we're going to go ahead and attempt to factor the x squared minus 3x minus 4. And that's going to factor as x minus 4 and x plus 1. And now we can go ahead and do the solving portion. Because it's factored, we've done this several times, we're going to take the factors and set them equal to 0. And then when we solve, we get two answers of x is equal to 4 and x is equal to negative 1. Now again, we have to double check our answers to make sure that we don't have any extraneous solutions. So I'm going to take both of those values and we're going to be plugging them into the original expression to see if they work or not. Again, if we get a 0 in our denominator, that means that we have an extraneous solution. If we don't get a 0, then it's probably okay. All right, so let's go ahead and check the 4 first. If I plug in the 4, then we have 1 over 2 times 4 plus 5, and we want to see if that's equal to 4 over 11 times 4 plus 8. On the left side, we're going to get 1 over 13. On the right side, we're going to get 1 over 4 over 52. And if I reduce 4 over 52, I do get 1 over 13, so we know that it is, in fact, correct. Now, we're also going to go ahead and check the negative 1 as well. All right, so if I plug in that negative 1, then we're going to have 1 over 2 times negative 1 plus 5. And we see, does that equal negative 1 over 11 times negative 1 plus 8. Now on the left side, we're going to get 1 over 3. On the right side, we're going to get negative 1 over negative 3, which is going to equal, again, 1 over 3. Now again, I did the physical check here. I'm not asking you to write down the physical check, just make sure that you are checking your answers to verify that they both work and that we don't have any extraneous solutions. All right, you see over here on the left, we've got this Desmos and this graph and sketch. If we were in class, we do a follow-up activity to kind of verify that the algebra and the graph sync up, but unfortunately we're not in class, so we're gonna go ahead and skip that aspect for today. All right, looking at our next one, I would like for you to go ahead and try this one. You want to cross multiply, solve for your variables, and then check your answers. Make sure you don't have any extraneous solutions. Go ahead and hit pause and then check back in and see if your answer is correct. Okay, so you can see my work here. The right side gets a little complicated, but let's walk through it. I cross multiplied, and then because I had an x squared, I combine everything on one side to get 2x squared plus 3x equals 0. After solving, I got factors of x and 2x plus 3, which gave me the zeros of x equals 0 and x equals negative 3 over 2. And when I checked them, I saw that if I plugged in a 0, then my fraction on the right became 0 over 0, and we can't have that. So then that was an extraneous solution. When I plugged in negative 3 over 2, again, it's a little complicated. You can follow my work here, though. We got on the left side, the fraction was 2 over 7. And eventually, on the right side, the fraction was also 2 over 7. It matched up, so we know that negative 3 over 2 was, in fact, a correct answer. Okay. A couple more examples just to kind of make sure we clarify this process. We're, again, going to start with cross multiplying. I'm going to get x squared plus x is equal to x squared minus 5x plus 6. And that's what I get when I would multiply x minus 2 times x minus 3. Okay, so we do want to go ahead and get everything together on the same side. You gotta have a choice here. I'm going to move everything over to the right side. So we're going to have 0 is equal to, the x squares will cancel, and then we get negative 6x plus 6. We're going to go ahead and solve for this. I'm just going to add the 6x back over. Since I don't have an x squared, I don't have to really factor. And then divide by 6, and we get x is equal to 1. We only have one number to check here, so we're going to go ahead and plug that in. Again, we're just going to take it and plug it into the original expression to check. If we do, we're going to get 2 over negative 1, and that's going to equal negative 2 over 1, and negative 2 definitely equals negative 2, so I know that that is an answer. Okay, one more for you to try here. Again, go ahead and cross multiply, combine like terms, and then do what you need to do to solve for x, and don't forget to check your answer. Hit pause now and then check back in to see how you did. All right, so we had the same steps that we had for all of our other problems. I started by cross multiplying. When I multiplied 2x plus 3 times 2x minus 3, I simplified it to be 4x squared minus 9. This is the factored form of the difference of squares, so if you recognize that, it kind of makes it faster when you're multiplying. And then on the right side, we got 3x squared. Because I only had x squared terms, I combined them to get a positive x squared, and then I moved the negative 9 to the other side. So I got x squared equals 9. And then don't forget, when you take the square root on both sides, you have to add in plus or minus. When I checked both the positive 3 and the negative 3, it worked out. I got equal statements on both sides of my equal sign. So both 3 and negative 3 are, in fact, solutions to our problem here. All right, that does it for your notes. The homework is on the other side. Go ahead and get started, and good luck.